Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by Cachefly at CACHEFLY.com.
This is Floss Weekly with Randal Schwartz, episode 140 for October 27th, 2010, Rakudo Perl 6. It's time for Floss Weekly, the show of free, libre, open source software brought to you weekly by me, Randal Schwartz, your host, Merlin at Stonehenge.com. Well, at least most of the time it's weekly. I'm having to skip a couple of shows because I'm out on one of those wonderful Insight cruises. Right now, probably as you're listening to this, I'm somewhere in the Western Mediterranean. But while I'm toiling away, drinking those little umbrella drinks, I still am bringing you a show, a very special show, in fact. I've been involved in the Perl community since just about the very beginning in all sorts of different ways and respects. First just a user, then a sort of an advocate for Perl on the early Usenet, and then, of course, the author of the original Programming Perl, the Camel book, which set lots of sales records for O'Reilly when it first came out, and all sorts of things. I wrote still the best-selling Learning Perl book, which is the book that everyone turns to get their introduction to Perl. And so I know a lot about Perl, and the current sort of production version of Perl is Perl 5, and Perl 5 has been around for a real long time. But somewhere around 10 years ago, we had the idea in the Perl community to go ahead and rev it a bit, because it was getting a little stale, a little dusty in the corners. So we started the Perl 6 project about 10 years ago, and I know that seems like forever in the computer industry, and some have said, well, Perl 6, that's like Duke Nukem Forever, right? It's not actually coming out? Well, I'm sorry to say it actually is coming out, so all those naysayers are going to have to eat crow on this one. And in fact, in order to talk about where Perl 6 actually is, I have a very special guest today, Patrick Michaud. He's the lead developer, we call it the Pumpkin, for the Rakudo Perl 6 compiler. Rakudo Perl 6 is a specific implementation of Perl 6, because Perl 6 is a language spec now. It's not just a specific implementation. There are actually multiple implementations of Perl 6 so far. So I'm going to bring him on today to talk about where we've been, where we're at now, and where we're headed in the whole Perl 6 effort. So very special show. I also don't have a co-host this week because I thought, well, you know, I can probably hold my own when it comes to asking Perl questions. So let's go ahead and bring our guest on. Hello, Patrick.
Hello.
Hi, where are we speaking to you from?
I am in Plano, Texas.
In the beginning of the show, I sort of introduced, because I do know a little about this subject. I should be somebody who knows a little bit about this subject. I sort of introduced, how we got to Perl 6 and stuff like that. But really, let's revisit that. I really want to go in a little bit of depth of what the history of the Perl 6 project has been and why it even got started. Can you give us sort of the overview of that?
I can give you what I know of it because I wasn't there at the beginning.
Oh, true.
But Perl 6 arose out of the Perl conference in 2000 when people were looking at how do we go to the next phase of Perl 5 development, because Perl 5 had kind of stalled. It was kind of getting difficult to add features in, and finally it was decided that in some senses we needed to start over and to kind of see what we could do if we started from scratch. And not worry too much about backwards compatibility. Of course, one of Perl 5's and Perl 4 as well, big features has been that it pays a lot of attention to backward compatibility. That programs that were written a decade or so ago will still run on Perl today. But when you have that kind of backward compatibility, you're kind of stuck with decisions you made a decade ago. And so we said, what could we do if we had some things to do over again? What would we do? And so out of that came the idea of Perl 6, that we would have Perl 6. From Perl 6, once they said, okay, we're going to have Perl 6, Larry and other people who were putting it together started a process called the Request for Comments series, where people could say, if they could fix something in Perl, what would they fix and what would they like to see added? And Larry has told me that at the time when he started the Request for Comment series, he only expected to get a couple of dozen. And of course, he got over 300 requests for comments.
Yeah, I remember that.
And so whittling that down where it was not going to be a small task to try and synthesize those together to make Perl 6. And the other thing that Larry said is that the comments that he got, many of them were contradictory. That somebody would say, well, I want to do this, and somebody would say, I want to do this other thing, and you couldn't do both without doing a lot of deep understanding of what was going on and trying to synthesize the two into some third thing that would handle the first two. And that took a long time to get together. So Larry started out by taking the comments and creating a series known as the Apocalypses, where he brought together the ideas and introduced the different things and said, okay, we're going to design this new language. And in fact, one of the big stumbling blocks was even how do you design the new language from scratch? And finally, he decided that the way to do it was to follow the chapters in programming Perl, because as he said, he wanted to minimize forward references. And if you're introducing a language, that's for teaching purposes, you do the same thing. And so he started with the basics and began evolving things into the apocalypses. And that took place over the course of a couple of years. And they started doing implementations. Originally, the idea was we could implement a lot of these Perl 6 features on top of Perl 5, at least for testing. And so there was a Perl 6 compiler that was started and Perl 6 modules that were created that would run on Perl 5 and were placed on CPAN. A lot of different work with that. Around the same time, some people said, you know, a lot of the problem that we have with Perl today as it existed back in the early 2000s is that the code base had become very crufty. It was very hard to maintain. So perhaps it was time for a new virtual machine to run Perl 6, a new basis for the actual runtime engine that would take place. And that eventually became Parrot. And it was a very ambitious goal at the time because they said, let's make Parrot not just to run Perl 6 and also Perl 5, but to run all sorts of dynamic languages. And so the Parrot project was begun to be a virtual machine that would run many different dynamic programming languages. So this would include things like Ruby and Python and PHP and the like. And then we could explore the notion of having a common runtime environment for all the dynamic languages, and maybe someday they could even work together and talk to each other.
I don't want to skip over the fact that Parrot was actually named after a joke. Do you know the joke? Yeah,
the joke was an April Fool's joke, and the idea behind the joke was that Larry Wall, the creator of Perl, and Guido van Rossum, the creator of Python, got together and decided to create a common programming language called Parrot that would be kind of a mix of Perl and Python. And then when it was decided to create the runtime engine, they said, well, we should just call it Parrot since it would support both.
Yes.
So yes, there's as with all things Perl, there's all sorts of funny in-jokes and things that take place behind the scenes.
It's one of the things I like about the culture. Yeah. So Parrot was created to be this engine for what was becoming Perl 6. And how did that get started, and who was involved?
Let's see. Well, Simon Cozens started it first. And I believe it was also based on work that Chip Salzenberg did with Topaz to do it. And so they started it first. After that, it was taken over by Dan Sugalski, who became the Pump King for the Parrot effort. And he wrote quite a lot of articles on the architecture and how the virtual machine would be put together. For one thing, he made it a register virtual machine instead of stack-based virtual machine, as a lot of other virtual machines have gone. And his reasons for doing that was that there was a lot of compiler history to support a register machines and knowing how to optimize them. And so he felt that going with a register-based machine would be much more powerful in the long run. Then after, so they worked on that for about two or 3 years, and this is where I came into the picture. Actually, is in about July 2004. It was felt that the Parrot had gotten too big for one person to be doing both the Perl 6 part and the Parrot part. And also that the modules that had been put together in the fledgling Perl 6 compiler that had been put together as of 2004 was becoming itself unmaintainable. And so there was also a sense that maybe we needed to start over. So there was a call put out for a Perl 6 compiler pumpkin. And I happened to be available at the time, so I threw my hat in the ring and said, I'd like to give this a try. And I had some time off from my other job, so I could devote some time to it. And lo and behold, they selected me. At which point I said, "Oh my God, what have I done?"
You're still wondering that today?
And I still wonder that today. And at the time, I thought to myself, I'll spend a couple of years working on this, and then I can turn it over to somebody else, and we'll be in good shape. But that was 2004. Here we are 6 years later, and I'm still working on it.
It's like how I got involved with Perl in the first place, because when Larry put out the call for Perl 3 beta testers, I said, "Oh, I've got a little spare time." Don't anymore.
And yes, and that's that appears to be how a lot of these things happen.
Yeah.
So I joined the project then, and so my work starting in 2004 was to work very specifically on writing a Perl 6 compiler. And
what does that mean? Does that mean take the language as specified in the current apocalypses and translate them into Parrot code?
That is what that means,
okay.
Exactly. So to take the apocalypses, and by that time Larry had also begun to summarize them, or he started summarizing them that summer, as a matter of fact, into what are called the synopses. And the synopses, the apocalypses tend to define, the justifications for why things and the logical process by which Larry came up with the ideas. But we wanted something that was more of a summary, more of a specification. And so the synopses get rid of all of this is why we chose to do these things, or here's the history behind this idea, but just what is the idea and how does it work? And so those ended up becoming the Perl 6 specification. And my role as the Perl 6 compiler pumpkin at that time was to start to implement the specification, actually build a compiler so people could write Perl 6 source code and run it on Parrot.
Now, what language were you implementing this in?
Parrot has its own language, it's basically an assembly language called PIR, for Parrot Intermediate Representation. And that's essentially the language to choose from at the time that I started. So most of the stuff I was doing in 2004 and up through about 2007 was all written in PIR.
So you're writing a Perl 6 compiler that essentially translates code to Perl 6 code to PIR. You're actually writing it in PIR.
That's correct.
Oh, okay.
And that's so that's where we started. And I decided that the first component that I would have to start with in 2004 was to actually get a grammar engine. Perl 6, the language, is very, very tied to the way that it thinks of regular expressions and pattern matching. They are inseparable. And the grammar itself for Perl 6 is written in Perl 6. The parser is written in Perl 6. All of the core components, at least in their design, are thought of as being Perl 6 components. And so in that sense, it's kind of a self-hosting language. And so if we were even going to begin to parse Perl 6 programs, we needed something that could do that parsing. And so I started out by writing a grammar engine that would understand Perl 6 regular expressions and could begin to parse Perl 6 programs in the way that Perl 6 would want them to be parsed.
But you're not writing it in Perl 6, you're writing it still in PIR.
At the beginning, it was in PIR. The idea was to bootstrap it, to start it in PIR and get a Perl 6 grammar engine that could read Perl 6 programs and then rewrite that in Perl 6 so that it would be done in all in Perl 6. That was the long-term goal. Short-term goal was to get something working. Because even as of 2004, 2005, when I was working on this, people were getting impatient for Perl 6. It's funny to look back on those days now, 5 years later.
If only they knew.
Yeah. But in 2004, 2005, people were asking, okay, so we've been talking about Perl 6 for about 4 or 5 years now. Where is it?
Right.
And so I wanted to show progress quickly. So more important than bootstrapping was to just get something going with Perl 6.
And this was even before Pugs, right?
This was just before Pugs.
Okay.
Pugs started in January of 2005. So just as I was finishing my first fledgling efforts at the grammar engine, Audrey Tang, it was Audrey's Tang at that time, but Audrey Tang started a little research project in Haskell to say, what could we do as far as parsing and writing Perl 6 programs with Haskell as a back-end engine? And it was really just done for fun. well, which is the way that a lot of good projects get started. And it just kind of mushroomed from there. Audrey started out by saying, okay, let's do basic expressions, and then implemented junctions. And junctions, to me, at the time when I thought of junctions, so for people who don't know what junctions are, if you're familiar with Perl, Damian Conway created quantum superpositions module. And the idea is that you can have a scalar variable that holds simultaneously multiple values, and you can reason about those values in parallel. Much like quantum mechanics or quantum dynamics would tend to do. And so he implemented that in Perl 5 as a module, and people kind of thought, okay, that's cute and interesting and all sorts of things. But when it came time to Perl 6, we realized, or the designers, it wasn't me, Larry and Damien realized that this actually has value, that there are times in a program when we want to talk about several simultaneous possibilities.
But essentially, it's set arithmetic. You're finally operating on sets and showing intersections and unions of sets, and like adding constants across all members of a set, things like that.
Actually, it's not set arithmetic. It does have sets in them, but it's not pure set arithmetic, because one of the problems, or one of the challenges we have in the Perl 6 specification now is that people want to treat junctions like sets, but you can go through and they act like sets to get you a final answer, and you can get a true or false answer that says, yes, something is in the set or it's not in the set, but you can't tell which one it is. So there is a challenge for that. Where junctions become useful is in things where we want to do tests for all of the members of a set, or any of the members of a set, or things like that. So, for example, in Perl 6, you can say if $A, variable A, equals 1 or 2 or 3 or 4, and literally write it out: 1 vertical bar, 2 vertical bar, 3 vertical bar, 4, and it will test to see if A is any of those values. Right. Without having to write a complex conditional where you say if A equals 1, or A equals 2, or A equals 3, and so on. And there's a lot of places like this where this just becomes very natural to write in throughout the language. We can talk about junctions of types. Is this variable an integer or a string? We can talk about junctions of functions. There are a lot of just really powerful capabilities that show up when you put this as a first-class primitive in your language. So Audrey was going to play with junctions because it was kind of new, it was neat, and so she implemented it in Pugs, and then pretty soon began to implement conditionals and then functions, and pretty soon you have a reasonable Perl 6 implementation on your hands. And so Pugs, just in the span of about 8 weeks at the beginning of 2005, suddenly became the Perl 6 implementation that everybody was playing with. And it was nice because people could start playing with this language that had only been talked about for, 4 or 5 years.
Now,
people could actually see what was in there.
Did it have a grammar like Perl 6's current grammar?
It did not. It had a grammar and could do parsing, but in Haskell, they already have a parser tool built in. So people who are in the Unix and C world, they're familiar with Yak and Lex, or Bison and Flex for writing parsers. In Haskell, they have a thing called Parsec, and it's a very powerful parser. And so Audrey wrote a Perl 6 grammar in parser using Parsec. Now, of course, that's Haskell code for doing that. As a result, that's one of the reasons why Pugs was able to come together so quickly, because they already had a good parsing tool available that could be used to parse the basic Perl 6 code. So so that part was different. That part was not really following where Perl 6 would ultimately need to go. So that's the beginning of 2005 is what is now, by all the people involved, considered to be Perl 6's golden age of development, and the work that was done with Haskell and with Pugs in doing Perl 6, because it was the first time that people could really sit down with an implementation, play with the language, see what worked, see what didn't work, and to build from there.
I also remember that part of the experience from that was that Audrey was able to point out places in the spec that were unimplementable because they weren't specified yet.
That's correct, or even contradictory.
Yeah.
And there were places in the spec that were contradictory, that were underspecified, where Things just couldn't work the way they were specified. There was a lot of that going on, and so that was really nice. From my perspective, where I was looking at a longer term Perl 6 implementation, it was a little frustrating maybe to be upstaged by pugs, but it was also I also knew it was very useful. And in the Perl 6 community, one of the things that's kind of different from traditional Perl and Perl 5 is that we don't look at there being only one implementation of the language. We look at Perl 6 itself as a language specification, and there will be multiple implementations of that language. Of course, a classic model for that would be even a compiler like a C compiler. There's a C language, and there's who knows how many C compilers out there, and they're able to coexist. And people are able to choose a compiler based on the characteristics that they want for whatever application they may be putting together.
So as pugs continued, you kept continuing on your activity as well, right?
Yes, because the one thing that pugs didn't have, being that it was based on Haskell at the time, is this idea that we might have language interoperability. And the thing that Parrot was aiming for, where you could have Python modules talking to Perl 6 modules and communicating with Perl 5 modules and those kinds of things. So I looked and we communicated between the pugs and the Perl 6 on Parrot projects fairly frequently. We kept tabs on what the others were doing and tried to cross-pollinate where we could. But yes, I just kept going on with the work I'd been doing because my goal was to come up with something that could work on Parrot.
And so what happened next? Would you release something that could actually parse the grammar then?
Well, it took quite a while. The Perl 6 regular expression syntax and grammar specification is nothing short of awesome. There are evil geniuses behind the work on the grammar, and Damien, of course, knows who we're talking about. That would be Damien Conway and Larry. In fact, after I had agreed to to start lead an effort for a Perl 6 compiler, and I was going through and rereading the Apocalypse 5, which is the one that specifies regular expressions, and seeing what all they could do, just as I was reading it, my jaw dropped at the idea of what Perl 6 grammars would be able to do. And in fact, as I was reading it, I was saying, there is no way that anybody will possibly be able to implement this. It is not achievable. And then I said, oh, wait, that's my job now. Okay, great. And that was actually an interesting experience for me to dive in, to start to write that. My background's in computer science. I've done language theory. I've played with Perl since the early 90s. So I kind of understand what's theoretically possible versus what could actually be implemented in things. And so for me to look at that specification and say, I just thought to myself, I'm not sure this can be done, but I had great faith in the people who said it could be done. So, and I wonder if they had equally great faith in me that I could do it, and if they were wondering if it could be done. So that was kind of the challenge at the time, was to write that grammar engine. So my whole first year and probably 18 months of working on Perl 6 compiler was just focusing on the grammar engine and getting that working. So it wasn't really until 2006 that I had a Perl 6 implementation that could even begin to look and act like something that someone would call, okay, we're writing and running Perl 6. Now, in all of this time, there were a couple of implementations of the grammar engine, just as Pugs had found. As I was implementing the grammar engine, there were parts of the spec that couldn't work. There were some substantial rewrites that had to be made to the section on regular expressions to understand how capturing parentheses would work and how scopes would work and how a lot of the pieces would go together. And that took a fair bit of time to refine that part of the spec to be able to do even the basic things that needed to be there. So I could write some simple languages and I could write some really fancy parsers. In 2005 and 2006, we were at the point where you could write a Perl 6 grammar and compile it and get a parser from it. And so we did some simple languages just as proof of concept things and so forth. And that's pretty much where we were by the end of about 2005.
So let me make sure I understand that. So I could run, this is PGE, right? The beginnings of PGE.
Yeah, this was called the Parrot grammar engine.
Okay, the Parrot grammar engine. So the Parrot grammar engine is written in Peer, runs on Parrot, could take a Perl 6 grammar and translate it to Peer. Is that what you're
translate
saying?
it? That's correct. It to Peer and could parse. And that what it created was a program that was a parser that implemented those regular expressions that were in the grammar that you wrote in Perl 6.
So you could then run text into that running program and generate just a parse tree, because it really didn't have much of the rest of the semantics, right?
Correct. Early on, you could generate a parse tree.
Okay, but that's exciting because that's self-hosting. It's at that point, if you could feed the Perl 6 grammar through it.
If we had a Perl 6 grammar.
Okay. Well, that hadn't come along yet then.
That hadn't come along yet. We knew some of the basic pieces.
Okay.
Now, where it did end up being useful, though, is that Pugs did not have a grammar engine or a way of doing Perl regular expressions. And so one of Audrey's early tasks was to get Pugs to be able to talk to Parrot. And so Pugs then would call out to Parrot, use PGE for regular expression matching, Perl 6 regular expressions, and bring the results back into Pugs and put them into Haskell data structures. And that's how Pugs did its regular expression support, was using the grammar engine on Parrot that was being developed for the Parrot Perl 6 compiler.
Wow, did it do that all in the same process, or did it shell out another process?
I think it shelled out another process, at least at the beginning. Who knows what happened at the end, because Audrey does some really magic things. Because
one of the concepts is that Parrot is actually an embeddable engine. You should be able to drop it into, say, something like Emacs and get all these languages as the language of choice for programming stuff in Emacs.
Yeah, correct. I didn't study the mechanics of how it worked. It wouldn't surprise me if it was embedded.
Okay, so what happened next? So PGE's out there. It's able to at least compile basic programmers. What happened next?
So we had that. So the next thing to do was to do the translation. Okay, you've got a parse tree. Now we need to get that to executable code. And we wanted to do this not only for Perl 6, but for a whole suite of languages. Because from the Parrot perspective, if you want people to write languages on top of Parrot, you've got to give them a suite of tools that make it easy to write languages. And so we now had the grammar engine, and that made it very easy to write compilers for Parrot, the parser part. And so now we needed to make the tools to do the rest of it. And we had a meeting in Portland in 2005 saying, okay, how do we get to the next step? And what we decided on was something that would be called the tree grammar engine. So if you can imagine that regular expressions parse strings, sequences of characters, the idea was to come up with some sort of a grammar engine and syntax that could parse tree structures, very much like XSLT or XML, things like that, but to be able to do translations on tree structures. So then you could transform a parse tree into an abstract syntax tree and then use the abstract syntax tree to generate code. So we started doing that, and we came up with Alice and Randal actually came up with the first implementation of the tree grammar engine, and I adapted it for a variety of different pieces and tested it with, and that's when we began to get the first fledgling Perl 6 compilers, was implementing that. Now Allison, for testing the tree grammar engine, the first language that she did it on is a language that she called Puny. So that has a little bit of history itself. From the beginning of the Parrot project, there was the idea that Parrot would want to be able to run Perl 5. And so there was an effort to make Perl 5 embeddable into Parrot, and that was called Pony, because everybody would like to have a pony. Allison, for TGE, she needed a language that she could work with to try and compile and generate code, and so she chose Perl 1 and called it Puny. Obviously, because Puny sounds like pony. It has uni in it, which means one, and it was a very small language to start with.
Nice.
It was kind of clever. So I took the work that she did from that and began to generalize it a bit more, and to start generating Perl 6 code and to generate a Perl 6 compiler, where you could take a Perl 6 program and have it compile down to Peer and then execute the Peer, and it would do the Perl 6 results.
Now, Puny was written in Peer?
Puny was written in Peer.
Okay.
And the tree grammar engine, TGE, had its own macro language that you would put around the peer that would say how to identify the tree structures and how to control things as you were going through and doing your parse transformations.
Okay.
At this time, we followed a lot of the lead that Pugs was giving us, because Pugs also had an abstract syntax tree representation and was also creating the, they were doing code generation to Haskell and to other things as well. And so we kept in very close contact between the two projects about what the abstract syntax trees were looking like, so that we wouldn't get too far apart down the road when we wanted to kind of bring these things together into a common specification.
Mm-hmm. And what happened from there?
From there, this would be late 2006 and then into 2007. We started to generalize TGE into this thing that became known as the Parrot compiler toolkit, where you would have a suite of tools. You had a tool chain for being able to create a parser. You had a tool chain for being able to create a translator that would translate a parse tree into executable code. Mm-hmm. And so we began building an entire tool chain and documenting this tool chain and trying it out with quite a variety of different languages. So we did, of course, Perl 6. There were some fledgling efforts with APL, where we implemented APL on Parrot. We did some tests with the TCL, the Tickle compiler that had been built. They tossed their parser that they had written in pure peer in favor of PGE and started doing translations that way. Mm-hmm. So a lot of different languages began using or a lot of people started languages on Parrot using the compiler toolkit. Because one, it was fairly easy to get a language started using the toolkit, which was one of the things we wanted to prove with Parrot, and it was a good way of fleshing out the toolkit to find all the pieces that needed to be there. Mm-hmm. In about 2007, though, it was becoming obvious that the tree grammar engine wasn't syntactically robust enough for doing the translations. It tended to create write-only code. The only person who could read the code for the translation was whoever wrote it, because it was mostly in peer, and there were a lot of problems. At the same time, Larry was working on his implementation of the Perl 6 grammar. The Perl 6 compiler that I had been working on for Parrot had its grammar. That grammar was written in Perl 6 because we could bootstrap that way. Mm-hmm. And Larry looked at the grammar I was putting together and he said, these parts are right and these parts are not right. And so he started writing a unifying grammar that all of the basically a reference grammar that other implementations could look at mm-hmm. when trying to do that. And that started in about 2007. Mm-hmm. And so he started his grammar at this time. And as he was writing the grammar, you could begin to see the places where the implementers were running into problems. He began to run into them himself. And one nice thing about having the language designer working on a problem himself is that those problems get resolved quickly.
Yes.
So we began to see how we could tie the parser and the code generator together in a way that was very Perl 6-like. And the breakthrough that I ended up coming up with was what are called action methods. So with a parser, you write how the code gets parsed, but along with that is a parallel, what we call an action grammar or an action object. And as each rule is successfully parsed in the grammar, it goes and fires off a corresponding method in the action grammar that will transform the parse tree that you just got, because you just finished a parse, into its equivalent abstract syntax tree. This happens while it's parsing. And I was able to add that into the compiler toolkit very quickly. And what I realized is that I could use these two tools together and create a very minimal Perl 6-like language. And that became known as NQP, for not quite Perl. And the idea behind NQP was the Perl 6 syntax was fantastic, but Perl 6 as a language has an absolutely huge runtime environment. There are classes everywhere. There's a bunch of built-in functions. There's all sorts of different pieces that take place. And I said, you know what? I want to have something that's syntactically easier to work with than peer, but that can be used to take Perl 6 code and generate peer code that doesn't have a strong a heavy runtime component. And that can be used to create the translators. And so in 2007, I wrote NQP. which was just a way of rewriting TGE and what TGE was doing using this new action method way of doing things, but also to be able to start using Perl 6 as our translation language instead of Peer. And that brings us to the fall of 2007. I got that working in the space of a couple of months. I worked on it off and on, leading up through the summer, and then finally just put my head down and got it working, and was able to get NQP running in a couple of months, and had NQP was also written in Peer, but inside the Peer code also existed in the comments the equivalent NQP code. So that for every routine I wrote in NQP, I knew how to write it in terms of Perl 6 already.
Wow, cool.
So that way I knew that when I had a Perl 6 compiler, eventually I could just switch over to that other code and everything would work. So in late 2007, once we had this new revised toolkit, we took all these languages that we had prototyped over the previous year and rewrote them in terms of NQP. And with the new tool set that came together. And
so for some of these, it was pure Peer early on, and then it was the early Parrot toolkit in the middle, and now you're rewriting it again in NQP.
That's correct.
Wow.
Yeah, there's been a lot of restarts and do-overs in this process, and in all phases of Perl 6. There are a lot of places where we end up, we prototype something or we build something and we say, that's not quite right, and so we figure out what needs to be right, and then we look at what we have and say, oh, we're gonna have to start over.
Now, just to make it also clear, the spec isn't done yet either. It's not even still done today. I mean, there's still changes being made even to the specification. Did that affect your work, that the spec continued to change, or was it mostly because of what you were discovering the spec was changing anyway?
It's a little of both. Now, for the last couple of years, almost all of the spec changes have been in response to implementation concerns or from people actually using the language.
Okay.
So early on, a lot of it was, these are features we'd like to get into the language. And over the last 2 or 3 years, it's almost entirely the specification changes are because we discovered, oops, that's not going to work. And we figure out what we have to do instead. So I redid that in 2007. We rewrote it. And we also, at that time, Larry made stronger noises that we could no longer, we should stop calling the compiler I was writing, we should stop calling it Perl 6 as a name, because we wanted to really separate the notion that the phrase Perl 6 denotes a language and not a specific implementation.
Right.
So for about the last year, the year prior to that, all through 2007, I had been trying to come up with a name for the compiler. And we went through a variety of things. We thought about calling it Onion. We went through and just came up with, none of the names really seemed to fit for what we were trying to do. And finally, Damien offered the name that we have today of Rakudo. And so that's how we got the name Rakudo. Now, the background behind the name Rakudo is Damien had coined this word, or coined this notion of Rakudo from the Japanese Rakudado, which means way of the camel.
Oh, wow.
And Rakudado means way of the camel, but if you shorten that a little bit, then it becomes Rakudo. Rakudo in Japanese means paradise.
Oh,
and so,
wow.
as we know, Perl 6, when it's here in all of its glory, will be paradise for people who program in it. So it was kind of nice to have this name. And when Damien suggested that we call the compiler Rakudo, I jumped on that name. I said, that is exactly the name that I've been looking for.
Right.
And so in January 2008 is when we dubbed the Perl 6 on Parrot compiler and started calling it Rakudo Perl.
Okay, now at when it was first called Rakudo, it still actually couldn't quite take a full Perl 6 program and run it yet, though, right?
It could, but it was a pretty simple Perl 6 program. So by that time, we had if-then statements. We had it would do grammars. You could do subroutines. You could do lists. You could do most of the basic operations. So it was at least Turing complete. And it had a lot of the different features that you would want for just a basic programming language. It didn't have all of the things that you would want for Perl, but it did hashes and arrays and those kind of things. So it was something that you could start playing with.
And so what's happened between then and now?
Everything.
Okay, we'll start the show now. This is all just warm up for me,
man.
thanks.
Well, about this time, first, because the compiler now was being written with Perl 6 source code, now all of a sudden it was a lot more accessible to people who wanted to start hacking on the compiler. And in late 2007 is when Jonathan Worthington began, who was one of the core key contributors to Rakudo Perl and Perl 6, began hacking on it. And he was interested in it because it was something he could hack on. It became accessible. It wasn't just peer. It was something that it was easy to make changes to. It was easy to begin extending. And his major interest was in the object-oriented features of Perl 6 and implementing those. And in the space of just a couple of months, the amount of object-oriented features that showed up in Rakudo Perl were, to me, astounding. I was completely shocked at how much could be done in just the span of a couple of months by Jonathan. And so, by late spring of 2008, Rakudo Perl, you not only had subroutines and the basics of most common things, but you had a class object system behind it. You could define your own classes. You could do inheritance. You could do lots of different object-oriented types of things that that Perl didn't have at this point, except from another project called Moose. So all of a sudden now Perl 6, you can start writing object-oriented programs, and it's starting to look pretty good.
But that was all in Parrot already, right? You just needed the syntax and the Perl side wired up to it?
No, not exactly. Well, Parrot already had objects. This is absolutely correct. And so it had method calls, and as a virtual machine goes, it had a lot of pieces there. What it didn't have, and still doesn't have yet, is a Perl 6 meta object model. Objects and object orientation in Perl 6 go just all the way down to the lowest levels of the language. And the object meta model, so we had classes and objects, but you start wanting to do introspection on the classes or to combine them in the various Perl 6 ways that can be done. And that has to be layered on top of Parrot. And in some cases, we have to lie to Parrot, and we have to kind of work around what Parrot provides, because Parrot has a very traditional object-oriented model that doesn't really fit with the very, very powerful Perl 6 object-oriented model. So there was still, it was more than just, figure out how to layer the class keywords and things onto Parrot's object model. In reality, it involved creating a new object framework that could lie on top of Parrot's object framework that could then be used by Rakudo Perl.
Does Perl 6 have enough syntax, though, to completely encompass what you could do in Parrot for interoperability?
Yes.
Okay.
Yes.
So what happened after the object stuff?
And it does, and in Rakudo Perl, so we have extensions that are not part of the Perl 6 language, but one could easily conceive that a non-Parrot implementation of Perl 6 could write a module that would provide equivalent capabilities. But we actually have the ability to get down to Parrot's assembly language from within a Perl 6 program.
Cool.
And we've done that in a functional form as opposed to just straight assembly language text, so that somebody who wanted to port a program that's intended for Parrot to another backend that doesn't have all those capabilities, they could create a glue layer pretty easily to be able to mimic the Parrot API.
Well, that's pretty impressive then. Yeah, cool.
Yeah. We've only done that within the last 18 months or so, but it's again been one of those things that once we've done it, it's made so much of the programming easier for the people writing Perl 6 and Rakudo Perl.
So Rakudo progresses after objects. What was the next big thing?
Multi-method dispatch, where you can have multiple methods and functions of the same name, but may differ in the types of their arguments and or the arity, the number of arguments that are there. Came next. More improvements to the grammar engine. We started building in more of the built-in classes and types. Of which Perl 6 has an incredibly rich library of classes and types. Things like enumerations, we started adding in. Multi-dispatch I already mentioned. Just more and more features. And at the same time as we're implementing all of these things that are in the spec, we're also revising the specification because we're finding the things that don't work or that are work but are really kludgy and don't seem to fit together. And so at this time, the specification, much like was the case with Pugs in 2005 and 2006, as we're working on Rakudo Perl in 2008 and 2009, it's hand in hand with the specification, so that they go together, so that they're both evolving together as we learn more about the language.
And I imagine you probably have some lockstep changes that are making to Parrot as well, because obviously some of the like the fundamental types might not have been implemented all the way, right?
That's correct.
So Parrot's evolving. Your compiler toolkit chain that creates the upper part of Rakudo is also evolving. How different is that now, like functionally, from say maybe a year and a half ago? Is it still pretty much a bunch of stuff written in Peer and some remnants of PGE and NQP in there? Is that still all recognizable as the same parts that you put in 18 months ago?
Somebody would look at it and they'd be able to recognize and see how we got to where we are from where we were then. But last summer of 2009, the people who were working on Rakudo Perl, we got together and we said, okay, it's been 9 years and we need to get to something that we can call a releasable Perl. Okay. It won't be complete, but it's Rakudo Perl by summer of 2009 was beginning to show that you could begin to use it for real applications. You wouldn't want to use it to run your banking system or fire off cruise missiles at anybody, but if you wanted to play with the language and start experimenting with Perl 6, then it was reasonable for that. And so we said, it's time for us to figure out a point at which we can tie a bow on something and say, okay, we've achieved something. And that's when we came up with the notion of what is now called Rakudo Star. And I'll explain that in a little bit more detail in a second. But as part of doing that, we also recognized that some of the core pieces for Rakudo, and in particular the grammar engine, were not going to get us to that next level. What had happened in 2008 and 2009 as we were developing Rakudo is that the standard grammar, the reference grammar that Larry had been working on, evolved radically. It radically evolved, and it came up with new features that were necessary for parsing the language that none of us had an inkling existed in 2005 and 2006 when we were working on the spec. We could see the problems that we were running into with Rakudo Perl, and Larry was solving them in the new standard grammar, and the only way to do that was with a radical change to the underlying grammar engine. So in late 2008 and all through 2009, I was confronted with the knowledge that I was going to have to go and radically rewrite the grammar engine in order to accommodate these new features that the language itself was going to require at a core level. And in summer of 2009, I ended up with the core idea, and I said, you know what? We're at a point now that I'm not going to write this stuff in Peer anymore. I have a toolkit. I'm going to rewrite the grammar engine in Perl 6. And I didn't do it in Rakudo. Actually, what I did is I said, I'm going to rewrite the grammar engine in NQP because NQP is enough there. Previous to that, NQP was only really good for compiling classes and simple subroutines. But what I ended up doing was rewriting the regular expression engine in NQP and adding it to NQP itself. So NQP is very much self-hosted. It is a Perl 6 syntax that is used to implement NQP and other things. So part of the reason for that also is that we wanted, from Rakudo, the Rakudo team doesn't want to have all of our eggs in the Parrot basket. There's nothing wrong with Parrot. We like Parrot. Parrot is a great platform for us to develop on. There's a few warts and some things that have to be updated. But from a longevity perspective and from a code base perspective, we really want to be targeting some other backend someday. And all of that Peer code was going to make that very, very hard to make a switch. And so I said, with NQP, we can start rewriting a lot of this into something that is self-hosting that we can target multiple backends with. This is not a new idea. Pugs had done it in its earlier days as well. where in addition to targeting a Haskell backend, they worked on a JavaScript backend, a Perl 5 backend, a number of different backends that would go from pugs, and it kind of got unwieldy to be able to do that for a variety of reasons, and it was slow and things like that. But last year when we were working on this, I said, Parrot's not the only platform out there. There's the Java virtual machine, there's the .NET platforms, there's a lot of different things. If we want Perl 6 to appear on those, I'd like Rakudo to be in that game. So we underwent a major overhaul of the entire grammar engine last fall of 2009, to bring it up to speed with the changes that were being made in the standard reference grammar, and also to bring in some other fundamental changes to the object model and things that Jonathan was working on. So in about December of 2009, we basically abandoned our previous line of development and redeveloped a new one that became what is now the new Rakudo Perl compiler. We just started a new branch, but we took out a lot of the guts and redeveloped them on the internals.
And what is it called?
It's still called Rakudo. At the time, when the branch existed but was not the main line of development, we called it NG for next generation.
Okay.
And when we had it to a level where we felt that it was good enough to be the main line, we changed it to be master, as it's known in the Git world, and the old line became known as alpha. So the alpha branch is still out there, and every so often we dust it off and see what it could do that we can't do today. But because there were some features it had that we still haven't implemented yet in the new branch. But so the old branch was called NG, and the old branch is now called alpha. The new branch was called NG while it's in development. It's the current master.
Now, it is a subset of Perl 6 that can take and parse and translate, and it has multiple output backends?
It does not have multiple output backends yet.
Okay, so it's targeting just Peer for now.
Yeah, it generates Peer at the moment. We are looking at what it would take to do that, to do some additional backend output backends. Jonathan's actually working on that as under a grant that he has through the Perl Foundation. And I have no idea when that will land. It's not our highest priority. It's something we're doing in parallel with some other tasks that are very high priority for getting us to the next stage of development.
So at this point, everything is written that's in Rakudo is either in Parrot, which is actually C, implemented in C, or in this almost Perl 6 language from there up. And that's what Rakudo Star is.
Let's see. The easiest way to do it, I do these numbers every once in a while.
Okay.
About a quarter of the code is written in Perl 6. Literally, it's compiled by Rakudo itself, or the runtime libraries. So many of the built-in classes, what we call the core classes and the core subroutines that are part of the runtime are actually written and written in Perl 6 and compiled by Rakudo itself to produce the runtime. That's about a quarter of the code. About another 30% of the code is written in NQP, which is Perl 6 syntax, but it's the lighter weight Perl 6. And that's the part that actually defines the parser and the translator.
Okay.
And we want those to be fast, as fast as we can make them. We're not fast yet, but we want them to be as fast as we can make them. And so that's written in NQP. Then about 20% of the code is still in Peer. These are low-level routines that we have to leave in Peer, or we haven't converted yet, or we have to leave in Peer because it does something that's not easily done from NQP or Perl 6, or we're very concerned about speed. So there's about 20% that's that, and whatever's left is C code.
Okay.
So it's a mixture of all of those. We expect to be moving to get rid of all of the Peer. By this time next year, I would bet we have less than 5% Peer.
Cool. And I think either I missed it or you haven't yet explained the star.
Oh, thank you for reminding me.
Yeah.
Okay, so one of the other things that we want to do in Perl 6, at least with Rakudo, is to make a distinction between the compiler and a distribution. And again, this is a change from what's happened in Perl 5. Right now in Perl 5, when somebody goes out and gets Perl 5, they get the Perl 5 translator, but they get also a large set of modules. that are the standard modules that every Perl 5 implementation is supposed to have. And because there's only one distribution of Perl, I mean, there are Strawberry Perl, there are other ones now, but at the time, when there's only one distribution of Perl, everybody wants their module to be part of the standard, to be part of the standard distribution. And that becomes a maintenance headache for whoever is responsible for that distribution. It also means that changes to the language were tied to changes in the distribution, and that can make releases take a very long time, especially when you're trying to promote compatibility. And when you have only one distribution, it's like it's the official one. Nothing else matters. So in Perl 6, just as we say there's more than one implementation of a Perl 6. There can be more than one implementation of a Perl 6 compiler. Within Rakudo, we say, and there can be more than one distribution, so that somebody could bundle a compiler with a set of modules and create a distribution that's targeted for, we'll say, web programming, while somebody else can take another set of modules and a compiler, which might not be the same version of the compiler that the first group did, that's targeted for, say, bioinformatics or scientific computing. And so we envision that ultimately there will be multiple distributions of Perl 6, each of which will pick and pull together modules and compilers that are appropriate for whatever market they want to target. This is very much like what happens with Linux today, where, of course, you have the Linux kernel, and people can choose which kernel they want to use and bring it together. And then we have all these different distributions, like Ubuntu and Debian and Red Hat and Fedora and the like. And they all package together the different open source packages and the kernel and get them all to work together to serve the needs of a specific market whose needs might be different from one market to the next. And so there's no longer this notion of a one distribution fits all. And we want to do that with Rakudo as well. So Rakudo Star is our first distribution of the Rakudo compiler with these additional modules that are being put together. And it's a series of releases where we're basically exploring what do distributions look like. So when a typical person says, I want to run Perl 6, what I would tell them is to go and get a release of Rakudo Star, because it comes with not only the Perl 6 compiler, but with some modules pre-compiled and pre-installed, and so that you can start doing things like you would expect from a Perl programmer, where they're used to having a bunch of modules available already. So we distinguish between the Rakudo compiler, which is the language part, and Rakudo Star. The other thing that separating these out lets us do is that they can have, and they do have, different release cycles, so that the people who are working on the compiler can continue working on the compiler and making compiler releases without having to be concerned about how that might affect the people who are using Perl 6 or Rakudo Perl 6. Because the compiler folks, their job is to be true to the language, and it's the distribution packagers who are responsible for choosing a compiler that meets the needs of their market and the associated modules and making sure they all fit together. And that helps us to distribute the load of managing the compiler building process, managing the distribution process, and so forth, where until recently in Perl 5, that was always handled by one person called the Punk King, and they invariably burned out because it was too much work.
Yep.
So that's another thing that we've done. And we needed a name for Rakudo, for our first Rakudo distribution. And last year at YAPC Europe, we had several names come across. We thought about just calling it Rakudo 1.0, but that has some connotations we didn't want. And finally, I just started calling it Rakudo X. Fill in the X. But in Perl 6, there's an actual term for fill in the blank. It's called whatever, and it's represented by an asterisk. And so the name Rakudo Star is actually Rakudo with either the word star or an asterisk, and it means Rakudo whatever, because I didn't know what else to call it. It also had some nice parallels with I like to think of it like the NASA mission to the moon, where they of course went through Mercury, Gemini, and Apollo, and each one of those represented different phases of the process of getting a person first learning how to get off the Earth, how to be in orbit, and getting to the moon and back. Star is our first phase after the compiler. This is where we're learning how to do a distribution. The next sequence of distributions that we come out with we'll call something different, but it'll denote a different series. It'll denote a transition change where we say we've now moved beyond just simply getting a usable Perl 6 implementation out there. Now we're going to focus on something else.
But there is actually like a version number to Rakudo Star as you make each release, right?
There is a version number. Right now we just use the year and month when it was released.
Oh, that makes it simple. Don't have to invent something then.
Yes.
Unless you slip, then it's bad.
We don't necessarily say that they're monthly releases,
Ah.
but just whenever it's released, the year and month that it's released, that's when it is. Currently, because of the rapid change of the implementation, we do monthly releases. At some point, I expect it to go to 3-month releases because the goals of a distribution are different from a compiler in that at some point, people are worried about deprecation and stability. And when you start bringing stability into the equation, frequent releases are not as important as having a stability plan across releases. And in some markets, I can imagine that some distributions would even go with yearly or 2-yearly releases, where they're just interested in that level of stability. So we envision multiple different timelines. But yes, for now we just do month and year to say which version of Rakudo Star we've released.
So Perl 6 has been a long time coming. Does the current release of Rakudo Star implement all of what's expected that Perl 6 will be?
Nope. And I have no idea when we'll get there.
Christmas?
Christmas, yes, of course. But I won't tell you which year.
Yeah.
It does not implement all of Perl 6, and there are numerous reasons for that. First of all, Perl 6 is huge in terms of what it can do and what has been designed for this language. Because our ability to imagine features we'd like to support far outstrips our ability to implement them quickly at this point, just because some of the features are just incredible of things that we're putting in. And so, we already have a roadmap for development that will easily occupy us if we did nothing else for the next year or 18 months to add more Perl 6 features. And, a lot of people will say, well, why don't you just, call it finished to say, okay, just stop adding things to the spec so that you can finish. And the answer to that is, well, even in Perl 5, we're always adding new features. The only real difference between Perl 6 and Perl 5 in this respect is that in Perl 6, we have a roadmap for where we're going. It's just taking us a long time to get there. Perl 5 has a roadmap for where it's going with a lot of the new features that it is creating on its own and borrowing from Perl 6 development. It just has the advantage of a longer history of actually being out in the wild and being used there. So the Perl 6 specification is so big and has so many pieces, and there are a lot of areas that we haven't even really explored yet, like concurrency and threads and those kinds of things. How do we want to do those in Perl 6? We could throw something out there, but without the benefit of an implementation and testing it, we know that whatever we speculate is going to change. So we're not really saying there's a point at which we know that we will implement 100% of the specification. I suspect the Perl 6 specification will always lead the implementations, at least to some small degree.
Okay, well, let's compare this then to Perl 5. How much of what's in Rakudo Star now was not in Perl 5? And maybe how much of stuff that was in Perl 5 that people found useful is not yet in Rakudo Star?
Oh, that's a good question. Well, the first thing to do is to say that when you load up Rakudo Star today, you basically have the equivalent of Perl 5 loaded with devel declare or moosex declare. So basically you have subroutine signatures plus moose loaded plus regex grammars, which is Damian Conway's new regular expression grammar module for Perl 5. All of that's already built in.
Mm-hmm.
So when you load Rakudo Perl today, those are already, they're running. They're loaded, they're running, they're there. So we have those. The biggest things that we have then that are advantages or extensions over what Perl 5 would give you then, we have the ability to do operator overloading, where you can define your own operators. Of course, we have a very rich typing mechanism. We have all of the multi-method dispatch available where you can do multi-methods and subroutines and things like that. We, of course, have roles and classes and those kinds of things. We have the hyper operators and the other form of meta operators built in. These are things like you can take any infix operator and turn it into a reducing list operator where it applies the infix operator on each of the elements of the list. That's built in. Hyper operators, which work on arrays in parallel, the zipping operators, all of these kind of things are already built into Rakudo Star. And those are things that we have that Perl 5 is either in the process of borrowing from Perl 6 or doesn't have yet. In terms of things that Perl 5 has that Rakudo Star doesn't have, number one is speed.
Do I dare ask how to compare them?
Rakudo is slow.
Okay.
And I mean, it is. We know that it's slow. We are working on the speed. We know what we need to do to make it faster. Our emphasis at this point has been to get something that works and to make sure that it's usable in the sense that you can write programs and evaluate it and be able to use it for some at least limited applications. But it's really, really slow. Now on the web and on various blogs, you'll see people who do comparisons of the startup time between, say, Perl 5 and Perl 6, and they show that Perl 5 starts up in in just a few hundredths of a second, and Perl 6 takes a second to start up. But it's not an apples to oranges comparison, because when you start Perl 6, you are getting the equivalent of Moose and the subroutine declarations and all of these other features already loaded.
Moose are 2 or 3 seconds right there.
Yes, exactly. And if you added regex grammars, then you'd add another couple of seconds. And so, if you just look at the startup time of the basic interpreters, it's not at all an apples to oranges comparison.
So speed is one. What else is Perl 6 missing that you might miss from Perl 5?
Modules.
Oh.
We're still new. And, this is always a disappointment when people find out about it. But Perl 6, the language, does not run Perl 5 modules from CPAN out of the box. We're working on that, but it's not going to happen anytime soon. So many of the modules that you're just used to always having because it's in Perl 5 haven't been written for Perl 6 yet. That's both a detriment, but it's also an opportunity. In many cases, for the core modules that you would really want, that are the common modules that everybody might be using, it would be better to rewrite them in Perl 6 to begin with, so they can be optimized for Perl 6 rather than trying to run the Perl 5 module already.
So Perl 6 has modules. It has a module system. It just doesn't have the equivalent of the CPAN yet. Yeah,
it doesn't have the equivalent of CPAN. So there's a DBI module that Tim Bunce is working on. I'm sorry, DBID module that Tim Bunce is working on and that is running, and he's given presentations about it. So we have that. We have some modules for being able to do web programming and some other. But when we talk about modules in the Perl 6 community, we're in the low, maybe the upper 90s, around 100 modules. And you compare that to CPAN where there's like 20,000 and you get a sense of the scale of the difference. So that's the other thing that Rakudo Star is intended to promote, is to start building that module framework or borrowing the module framework from CPAN to get more of these modules created and into the distribution and have them have testing cycles and the like.
And what else is Perl 6 missing that we might miss from Perl 5?
Let's see.
The equivalent of XS?
Yeah, no, we have that.
Oh.
Except in Perl 6, it's called NCI. It's the native calling interface. And Jonathan Worthington gave a talk where he showed how he was able to link to C routines from Rakudo, just basically using Rakudo. So it didn't even require a module. It was a trait declaration that he added to the language to make it work.
Wow.
So we can talk to other Parrot modules. It's kind of a limited communication. We can talk to C libraries already in Rakudo, so that's there. It could be made a bit more robust, but we definitely have, even like in the DBID or database interface and some of the other ones where people are already talking to C libraries and starting to make use of them.
You have sockets? Must have.
We have sockets. That we don't have asynchronous I/O. And the reason we don't have that is Parrot doesn't have that yet. And so that's one of the big things that we really wish was there. And of course, I'm just going to go to rakudo.org because it tells me.
So there are websites for people
yet,
yes, right,
that you might want.
Yes.
We don't have, let's see here, non-blocking I/O. We don't have Synopsys 9. So Synopsys 9 in Perl 6 is the equivalent of the PDL, the Perl data language. We don't have that implemented yet. But other things from Perl 5, I think, I don't see anything in this list here where it's something that somebody would expect coming from Perl 5 that is not in Perl 6, in Rakudo Perl 6 today.
Our format's finally gone.
Formats are finally gone.
Yay.
Until somebody writes a module for them.
Yes, it can be done by that. I know that Damien wrote one in user space, so it was sort of interesting in Perl 5, so I suppose we just look at how that's done and put it in Perl 6.
Yes, and that's been kind of the plan from the beginning. In fact, if you go look at Apocalypse 7, which was on formats, it basically says, now a module, see Damien.
Yes. Very good, very good. Okay, so that gives me a good sense of the timing and location. So you're coming out with new releases every few months, you said, or that's sort of the plan?
Well, for probably the next half a year,
okay,
we will continue to do monthly releases of Rakudo Star. And the compiler always does monthly releases. We have enough changes that we just do monthly releases for the compiler. Rakudo Star, which is what we expect people to download, will probably continue with monthly releases for the next 6 months or so. At that point, we may revisit it and say we'll go to a lower timeline. You can always go to perl6.org to find links to Rakudo and to all the other Perl 6 resources, and to find out what the latest release is. And I know that the distributions, the Linux distributions, are starting to bundle Perl 6 with the distribution. So Fedora 14 will come with Rakudo Star as a loadable module.
Very nice, very nice. What's the development team size look like? I know it's a cast of thousands, but like how many actual committers are doing something on a regular basis, and including the design team? How big is the design team?
I'd say there's about 24 of us who are pretty active.
Wow.
It's a good size, and it's continually growing. And we characterize the Perl 6 team as having, Larry characterizes them as rabbits and turtles. So we have some people who show up for a week or two, and they just do an astounding amount of work. I mean, just incredible things for a couple of weeks, and then they go off and disappear for a few months.
Wow.
They really will push forward on a particular problem, and and then they'll disappear for a few months, and then they'll come back and they'll push forward on another problem. And those are incredibly valuable people to have, because they can do things quickly, and they can try things out and push you along in new directions very, very quickly. Then we have turtles, and the turtles are the ones who just kind of work on it day after day. They don't necessarily do any big thing over a short period of time, but if you take all of the little contributions that they make over a long period of time, it adds up, and they're equally important because they provide a context, a stability, some continuity in making sure that there's always progress being made and understanding what's going on from one place to another. And so the team has got a lot of those, of both types, working on it, and some other, exotic characters who come in from time to time with their own characteristics.
If you could put out a request for a particular skill set that you might be lacking a little bit in, what would you be looking for?
Application programmers and module programmers. So people who write Perl 6 modules and people who write Perl 6 applications. The thing that we discovered in 2008 and 2009 with work that Carl Massak did, he wrote a wiki engine in Perl 6. It's called November. And what we discovered from that process was that nothing identified the places where we needed to improve Rakudo, like actually having people use it. And so what we want most is for people to be downloading it, writing modules, writing applications, telling us what works, telling us what doesn't work, both in the language and in the implementation. We try to be as responsive as we can, because these are the people who tell us, these are the people who help us actually get something done. Without the module programmers and the application programmers, we can flounder a bit, or we can focus on things that aren't really all that useful. So it's really, really nice to have those. So if I had my druthers of the kind of people I want involved, it's people who will come and play with the language and try it out and write some modules and applications and let us know and let others know about what they're doing.
And so when will Perl 6 be done enough that we can just abandon Perl 5?
That's not a goal of mine. And I see Perl 5 as being around for a long time. And it's kind of there's more than one way to do it. I see that over the long term, Perl 5 and Perl 6 will serve somewhat different markets. They overlap to a great deal, but you really can't and wouldn't want to throw away the incredible rich environment that Perl 5 has. And replacing that, there are some parts that will never be replaceable. So of the leaders in the Perl 5 and Perl 6 communities basically agree that Perl 5 and Perl 6 are two languages in the same family that will coexist for a long time to come. And by a long time, I mean, years, decades, that I would expect to see them around. They have a lot in common. They learn from each other. It's easy to take skills from one language to the other one. Each one has its strengths and some other parts that are maybe it's not so good at. And so when somebody says, when will Perl 6 replace Perl 5, I tend to say, you know what, I'm more interested in just making Perl 6 as good as it can be, as opposed to trying to replace any other language, whether it's Perl, Python, or anything like that. And just let the market kind of pick whatever language is best for them.
So you're saying that's the equivalent to asking, when will Perl 6 replace Python?
Yeah.
Yeah.
Or any other language. Yeah. Or when will C++ replace C? Yeah, like
never, I hope.
and that's what I suspect will happen, that languages that have value will be around for a long time. And there's often many people see a competition among languages, and I don't see a competition. I see a universe of languages that can each do their own thing in different ways. And ultimately, sometimes you want a domain-specific language. In fact, what Perl 6 is designed to do is to make it easier to write such languages in the future. So Perl 6 is not necessarily going to be the one language. It's going to be the basis for a lot of languages. So I don't see that there has to be one language that tries to do everything. Let's find out better ways to make all of our languages work together.
So you don't think maybe there's going to be a Perl 7 eventually once we get tired of Perl 6?
I don't even speculate on that. And if there is, I doubt I'm the one that's going to be doing it.
You'll have been through your phase of burnout as well.
Yes.
Very cool. Well, is there anything we've left out? We've chatted for a while here.
There's plenty. I can go on about Perl 6 stuff for hours, because we didn't talk about, say, like some of the features that Perl 6 has, but and it would take forever to go through them all. So I would say go to perl6.org and look at many of the blogs. Last December, we did a thing called the Advent Calendar. You can do a Google search for Perl 6 Advent Calendar, and you will see that we just every day somebody did a blog posting highlighting some feature of Perl 6 as it existed and as was runnable, and still is runnable on Rakudo Perl, so that you could see some of the really neat features that are coming together.
Yeah, I can easily see us spending another hour just talking about all the cool things that Perl 6 actually has in it. So
yeah,
because I know that back when I was looking at the earlier RFCs and the early specifications, I was going, this is really the language I want to be programming in, but I'm stuck in Perl 5 for a while.
And this is really the language that many of us want to be programming in, and that's why we're working on it.
Yes, very cool, very cool. Well, I really appreciate taking time out of your day to talk to me today about the efforts you've been putting into, and everybody's been putting into, to have Rakudo out there and available for people to use. And I just want to thank you on behalf of our audience.
Well, thank you very much.
That was Patrick Michaud. He's the lead developer, we call it the Pum King, for the Rakudo Perl 6 compiler. He's been in that role since 2004, and obviously it sounds like he's had his hands full. There's a lot of moving parts in something as complex as a full-blown language, especially a language with the kind of depth and breadth that Perl itself has proven to be. And Perl 6, of course, has big shoes to fill as it continues to be the language of the future for the Perl community. I'm really glad I got a chance to chat with him, and I actually found out a few things myself throughout the show, as you probably noticed my surprise on a couple of items. So it's good to always chat and be chatted with about things that are going on, even in your own industry. Very cool. So I'm skipping a show again next week because I'll still be on that cruise, so won't have anything next week. But immediately following that, we've got a fully loaded schedule. We've got James Phillips is coming in to talk about Membase. We've got, I'm going to mispronounce this name, I'm sure, Karanbir Singh, who is going to talk to us about CentOS, the sort of rebranded, not rebranded, but recompiled Red Hat clone, essentially. John Abbey is going to talk to us about Ganymede, which is a metadata management system to allow you to deploy things like DNS and all that stuff across multiple systems. Thomas Gorant is going to talk to us about GPL Host, which is a provisioning system for Linux systems, get you up and running quickly on a bunch of a cluster of machines. Then a really exciting show. Not that the others aren't exciting, but I'm really looking forward to this, and I hope we get some good video on this one as well. David Ankers and James Cotton are going to speak to us from down under, I believe, in New Zealand, on the Open Pilot project, which is UAVs that are running completely open source software. So imagine flying an unattended aerial vehicle around under the control of your own open source software. Really looking forward to that one. Mark Laporte's then going to follow up with us on TikiWiki, which is a content management system of a different flavor, sort of a wiki-based front-end thing, managing all of your bug reporting systems, bug tracking systems all in one place. So real good set of guests coming up. If you have a guest that's not on the list that's linked to from twit.tv/floss, then you can have the project leader email me. I'm merlin@stonehenge.com. Just have the project leader email me, and I'll put them on the short list. If you just suggest a project name, I'm probably going to just kick back that and say, hey, why don't you go ahead and get the project people to actually talk to me, because that saves me a whole lot of time, really it does. You can follow me on Twitter. I'm Merlin, Merlyn. You can listen to me reading science fiction shows by going over to starshipsofa.com. I've been doing an occasional piece for them. Really enjoying that as well. I don't have any kids, so this is my way of sort of virtually reading to the next generation, regardless of where they are. You can also hire me for Perl or Smalltalk work or training. You can also come with me on an upcoming cruise, just like the one I'm on right now at insightcruises.com. Has a bunch of future cruises listed there. There might be one that piques your interest. That's enough plugging on my own, and I would normally have my co-host plug their things right about now, but I don't have a co-host this time. I'm on my own. But we'll see you again next time on FLOSS Weekly.